this antiderivative will look like this. Hey, Mr. Grimm, it's the antiderivative of the sine of 2x or something. Now, let's think for a moment. Antiderivative of 2x. Wait a minute, sine of 2x. Wait a minute. I feel like if I told you to take the derivative of sine of 2x, you'd use the what rule? Chain rule. Thank you. I'm pointing here. Thank you. Yes, the chain rule. So in essence, what we see is we see a function and a function, yes? So if you're going to integrate something that looks like a function and a function, you will be using what is called the substitution rule. And this is what you're going to do. You're going to say, let's let u equal the inside function. That's it. Well, it's almost it. Hey, check it out, shall we? What is the derivative of u? What is du? What is the derivative of this with respect to x, dear? 2. That's right. So we say 2 dx. You see that? That's it. That's it. Yes. Okay, we're not done yet, but yeah. So watch. Over here, I'm going to say this is the same as the sine of u. Seppa, here's a problem, dear. I only have a dx. Ah, crap. Mr. Grimm, I don't know what dx is. I think you do, Seppa. I think you think it's 1/2 of du, don't you? Had a girl, nice job. And so I'm going to replace this with one of these guys. Voila. And now we are ready to integrate. Where did sine come from? Negative cosine. But what about this half out front? Dude, it just tags along, dog. Okay. Now, if you turn this in, I will take 1,000,000 points off, like this. If you turn this in just like this, I will take off minus 1,000,000 points. The question was about x, friend. Had nothing to do with u. So when we're done, what do? We re-substitute, yo. And what is u equal to? 2x. Ta-da! Ta-da! Thank you. Suppose I want to take the derivative of this to check myself, dear. What is the derivative of negative cosine? Well, it'd be what? It'd be sine. That's right. And dear, I feel like it'd be, so this 1/2 would stay out front. It'd be sine of 2x. And then you would times it by 2, wouldn't you? Because of chain rule. Oh my gosh! That's what I started with. Well, duh. It better be. Or you screwed up. Okay, that's it. You will do these. You'll get good at them. They're not hard. Well, not the easy. The early ones aren't hard. They'll get messier later on. It's okay. It's all right. Let's try this one. Can I do another one? Let's try another one. Let's try this one, friends. Mr. Grimm, what if I want to take the antiderivative of... Oh, by the way, last night, screwed this problem up in my class last night. So bad. It was so dumb. What's going on here, Mr. Grimm? Oh, I know. Ask me. Hey, feel like... Check it out. What if this was just a big fat x down here? What is 1 over x the derivative of? The ln. That's right. But instead, I have this stupid 3x minus 2. So I substitute. So du equals 3 dx. Every freaking time. I'm trying to help you. This is the rules. So when I take and do the substitution, it's going to be 1 over u. That's hot. But look, I need to get dx. Oh, look, my dx is what? It's 1/3 of a du. What does that say, by the way? It's saying to me, friends, that u is changing 3 times faster than x is changing. That's what it's saying to me. Literally, that's what it's saying to me, which makes sense because u is this whole thing. And x, when the x goes from 1 to 2, u goes from, well, forget this for a second. U goes from 1 to 6, doesn't it? Yes? It changes 3 times faster because of that 3 right there. Okay? What?
So what happens to the 2?
That's a good question. What's the derivative of a constant, sir?
Oh, yeah.
It goes away. Nice. Nice. It's hot. So listen. 1/3 out front. Du right here. Where did 1 over u come from? Why, Mr. Grimm, it came from ln. You're not wrong. We're going to talk about why that is today. And this is stupid. Again, you'll lose 1,000,000 points if you turn that in. So the actual answer is 1/3 ln of 3x minus 2 in absolute values plus c. Yes, let's talk about that ln business some more, shall we? Okay. Do you recall back in the day when we took the derivative of the natural log? We just wrote it like this, and you said it was 1 over x. And I said, well, technically that's true. But what is the domain of ln of x? If you've forgotten, it's just this fella. X bigger than 0. Yes? That means that the domain of this guy is also x bigger than 0. Okay? It's only this portion of it. Are you with me? Mm-hmm. However, going the other way, if you start with this fella, right? And you're like, where did this guy come from? People would say, ln of x on this side. Yeah, I would agree with you. Sort of. But what happens on this side? Oh, it doesn't work. But you know how you fix that? You take the natural log of the absolute value of x. And when you graph that, you get this fella. What? And so this guy is the antiderivative of 1 over x. Okay? Why is that? Because this one, x does not equal 0. This one also, x does not equal 0. You have to account for both of them. Okay? And you can look it up on, well, this is the picture. I don't need to graph it on Desmos. I mean, that's the frickin' picture. If you want to go graph on Desmos, go for it. But that's exactly what the picture looks like in Desmos. I don't think I need to do that. Hey, what is the slope over here? These are all negative slopes. Duh, that's what this says down here, isn't it? Hey, these are all positive slopes. Well, duh, that's what this says right here, huh? The same. There you go. Nice and good. Hey, Mr. Groom, I don't feel like I have to do anything with this 5 because the 5 is just going to be 5x. Well, I know that, and you know that. But this portion here is kind of weird, isn't it? Is there a function in a function? I believe there is. And I believe that function is x over 3, is it not? And so what would the derivative of that be?
3x.
Nope. Nope. Another way to write this is 1/3 times x, isn't it? So what's the derivative of that? There you go. Nice. Hey, that's hot. And so now be careful. That's 3 du is equal to dx. Now, notice I've done this in my head. I have done this intermediate step where I've done this piece here and this piece here. You with me? I did it in my head. I can do that because they are limits, yes? And the sum of the limits is the limit of the sum, right? Limits. Sum of the limits. You know what I'm talking about. I can do it in pieces. So this piece was easy. Sweet. How do I do this piece? Well, I'm going to change this to e to the u, yes? And then I'm going to replace dx with 3 du. Okay? Now, what are you looking at, bro? Some nice pants.
Yes.
All right.
So is that...
We're not done.
I'll just make that 5.
This no, it's just part of the, well, it's not part of the problem. It's, I'm just keeping track of it with me. I mean, this is part of my final answer, but it has nothing to do with this piece here, yes? What is the antiderivative of e to the x?
E to the x.
I know! Why? Because it's its own derivative. It's going to be its own integral too, isn't it? Right? So it's going to be e to the u. And of course, you're not going to turn it in like this because that looks stupid. I'm going to resubstitute. So it's 3e to the x over 3. Is that right? Plus 5x. Plus whatever my constant was. That working for you? Is that okay for you? What's the matter, Seppa? I don't want to be here. This is dumb. Can we go home? No, you can't. Just quit looking at me, you weirdo.
Just keep going.
Okay. Fine, I'll just keep going. Mr. Grimm. Ooh, can we do a square root, Mr. Grimm? Hey, I would love to. 2 Ooh. Let's shake this up a little bit. Let's do x square root of 2x squared minus 5. Oh, that's hot. Plus 6 x minus 3 sine 4x. Oh my gosh, this is so hard. It's not hard. Let's start with the easy one, shall we? What would our antiderivative be here for this middle one? 3x squared. That's right. And look, watch me put a big plus c over here on the end of the whole shebang when I'm done. You with me? Right? I mean, I know that's all going to be on there. Let's do them one at a time. Let's look at this guy here. Let's look at this sine one, shall we? I'm just going to go to a new page, and I'll write that down. So negative 3 sine 4x. Do you see a function in a function? Yeah. So u is 4x. Therefore, du would be 4 dx. There's a dx here, yes, by the way. There you go. Mr. Grimm, I feel like I just have a dx, so that's good. So I have a 1/4 of a du is equal to dx. So all I'm going to do is start substituting. I'm going to pull that negative 3 out front. That's okay with you. It's freaking me out. Sine of u. And then I'm going to replace my dx with a 1/4 du. Look at it. Yes? I'm just substituting. So here's my question. Where did negative sine come from? Who is he the derivative of? Cosine, right? He is the derivative of cosine. So when I go back, it's going to be positive 3/4 cosine of u. Yeah, that's right. But like, I thought of it as positive sine. Well, that's cool. Then it would be negative cosine, but there'd still be a negative out front. Negative and negative is a positive. Nice. And so that's cool. However, this is not my final answer. My final answer is 3/4 cosine 4x. True that? Some people would say, is that plus c, Mr. Grimm? Yes. However, if I have a bunch of plus c's added together, a constant plus a constant plus a constant is equal to what?
Constant.
I know. So we only use just the one of them. Okay. So over here on this previous page, I'm going to have plus 3/4 cosine 4x. And my plus c is already over here somewhere. There it is. I'm just going to put it right here. Get it a little closer. Okay? Now let's go look at this fella, shall we? This is hot. Some people would argue that this looks like a multiplication property. Is it 2x squared plus what? Plus what? Plus?
It's x square root of 2x squared times 5.
Beautiful. Some people would say to you, I think this looks like a product. I would tell you it looks like a function in a function. You with me? If it's a function in a function, you should start out with one of these fellas and do a substitution. What would du be? 4x dx. Oh my gosh, look at this. Miss Reardon, look. Look what I have. I have an x dx. How freaking cool is that? So what I have, you see, is 1/4 of a du. I have an x dx. So I'm going to get rid of this x dx over here. I'm going to replace it with a 1/4 and a du. You see that? Yes or no? If you don't see it, why isn't it up right now? Say it right now.
Oh, I see.
Dude, right on. Yes, no, maybe so? Where are you at, sir?
We have the dx onto
Where? Right, where? Here? Here?
yeah.
Well, because what I done was remember, I had the integral of this plus this plus this. Well, the integral of the sum is the sum of the integrals. So in other words, I'm doing them in pieces. I did this piece here, I did the sine piece, I did the 6x piece, all individually. Okay? Because that makes my life easier. All right? That is why we studied limits so hard back in the day. The limit of the sum of the limits. What is an integral? Integral is a limit. Okay? So it allows me to do this piece here by itself, do this piece by itself, do this piece by itself. Oh, by the way, when I'm done, add them back together. Okay? That's it. We're just doing one piece at a time. But they're still all areas, aren't they? So we're saying there's an area under this curve from A to B. There's an area under this curve from A to B. There's some area under this curve from A to B. Areas, plus areas, plus areas, total areas. Yes? Okay, well, we'll keep going and see what you think. Okay, now, this is going to be u to the 1/2 power now, right? Yes? And so the antiderivative is going to be, of course, 1/4 is still there. It's going to be u to the 3/2 times 2/3, yes? Right? Which, of course, is going to be 1/3. And then it's going to be 2x squared minus 5 to the 3/2. And you could always check yourself. Check it out. If you brought this down and multiplied it, what would you get? You'd get, why, Mr. Grimm, you'd get 1/2. You're right. And then you'd get 2x squared minus 5 to the 1/2. And you multiply by the derivative of the inside, which would be 4x. And this would cancel, give you a 2x. And I dropped a factor of 2 somewhere. Oh, no, there's a quarter right there, Mr. Groom. Yeah, that's right. So it's 2/3. So it's, wait. Oh, no, this should be 1/6. There you go. It should be 1/6. There we go. Which would then give it to you. Because that'd be 1/6 times 3/2. Cancel, gives you a 4. Ha! Gives you back where you started from, yes? So it should have been 1/6. My apologies. Let's get rid of that. Let's fix that. So this should have been 1/6. Okay? And so again, back to that previous page, it's going to be 1/6 2x squared minus 5 to the 3/2 plus this, plus that, plus that. And that's your final answer. Always remember you can break it into pieces. Okay? Just break it into pieces. Now, Shelby, that's enough of the substitution for today. This is our first day at it, okay? But Shelby, can I ask you a question? If I asked you, oh, whoa, Mr. Groom, I feel like I remember this guy. Do you remember him? What is that guy the derivative of? Extra credit if you can remember me telling you this. I used to have problems with this one all the time. Close. Arctan, baby. Yeah. Yeah. That's right, dog. Oops, not dx, you dummy. Plus c. That's right. But Mr. Groom has a question. This is not just x over here, squared. What would have to be in there? What would have to be in here so that you'd square it? It would be 3x, wouldn't it? Do you see that? Look at it. Is that true? It's a function. It's a function in a function, isn't it? Isn't that hot? So look, u is equal to, then what? U is equal to 3x. So du would be 3 dx. Mr. Grimm, where'd your dx go? I don't know. I just lost it. It's still here. I swear it's still here. It's right there. You see that? So watch. Watch me do the following. It's going to be 1 over 1 plus u square. But I need to get rid of the dx, Mr. Grimm. I know. I'm with you. I got you. And since that constant is there, I can pull the constant out front, yes? And write a du on the backside. Nice. So now you said that it looks like arctangent. I agree with you. It does look like arctangent. It's the arctangent. I'm going to go ahead and write of u. But again, I don't really want that. I want it to be back in terms of x. So 1/3 arctan of 3x plus a constant. That's it. Isn't that fun? Isn't that fun? Yes, sir.
So this only used when it's chain rule?
When it's a function in a function, yes, sir. That's right. But what if it's something different? Then it's something different. Yeah, it's one of those deals where, this isn't one of those. So we're going to have a bunch of different rules. Now, listen, Mr. Gibbs, check this up a little bit. I'm tired of doing the same thing. Oh, boy. not saying Luis like that. Luis. No, just don't. Yeah. As we mentioned yesterday, we know that the integral is simply a summation, but it's also a limit, yes? Limit of the sum of the limits, am I right? Meaning I can do this in multiple pieces, yes? Let's do the easy ones first, if you don't mind. Is that okay with you? Does that work for you? I'm going to do the easy ones first. I'm lazy like that. I just don't want to work very hard. Now listen, let's look at this one here by himself, shall we? Is there a function in a function? I feel like there is. So let's let u, somewhere, let's write this, u equal 2x. Therefore, du would be equal to 2 dx. And what I really have is this, then. A half of a du is equal to a dx. Now, allow me to demonstrate a little bit further down here by itself. What I'm really saying is I'm going to take this piece right here and treat it as its own integral. Does that make sense? I'm doing that piece as its own integral. And sometimes it's hard to see it unless you write it like this, because we're straight up going to, like up here, you have no problem with me doing this part here by itself, yes? You had no problem with me doing that, yes? But when you're doing the substitution, you're like, Mr. Grimm, I don't see a freaking dx right here. You with me? So sometimes I think it's more helpful if you rewrite this piece down here as its own separate problem. At first. After a while, you're like, dude, I know what the answer is. This is dumb. Let's keep moving. So watch. It's going to be e to the u. And I'm going to replace this fella with a half of a du, yes? And so what is the antiderivative of e to the u? From whence did it come? E to the u. That's right. Oops. Wait. I'm sorry. Well, it's equal to that. And then I'm going to resubstitute. There. Then I'm going to resubstitute and get 1/2 e to the 2x plus a constant, yes? Now, so every single one of these antiderivatives will have a constant, won't they? So a constant plus a constant plus a constant is a? That's right. So how many constants are we going to show, dear? Just one. Just one. So up here, dear, if you're playing along, up here on this deal, we're going to also have a what? A half e to the 2x. Are you with me on this? Well, Mr. Grimm, you forgot the square root. Bro, I have not forgotten it. I still have to do that piece too, don't I?
Yeah.
One thing at a time, baby. One thing at a time. Is it 4 minus 2? 2 minus 4x? Is it?
Yeah.
2 minus 4x. Hey, do you see a function in a function? Because I do. Hey, that's hot. So this is equal to negative 4 dx. Is that true? Yeah. That's what my girl Kimmy K would say, right? That's hot. Or one of those people. So, square root of u, yes? That's what I'm saying? Square root of u. And then I'm going to replace the dx with one of these dudes. Now, I can't do this in my head. I suck at math. I'm not very good. I have to do this on paper. Are you with me? I can't do it from square root. I have to do u to the half. To me, it's mind-boggling. I can't do it. So let's add 1. So what am I getting? I'm going to get u to the 3/2, yes? Divide by 3/2, which is the same as timesing by 2/3, correct? And then what about this negative 1/4? Well, it's a constant, so it just comes along for fun, yes? And so, Mrs. Stockton taught us how to do that back in the day. So it's 1/6 out front, negative 1/6, yes? U, but what is u? Isn't u 2 minus... Oh, no, it's not that. It's 2 minus 4x to the 3/2. Is that true? See, it's bueno. But
I'm confused with the 2/3 of these halves.
all right, let's add 1 to this baby. A half plus 1 is plus 2 halves. 1/2 plus 2 halves is 3/2.
Yeah.
Then I divide by that. If you divide by 3/2, you times it by 2/3.
So we're
Just like when you're going from x squared, if you integrate x squared, you're going to get 1. You're going to get x cubed over 3. Same thing.
Yeah. So we're using for 1. You said it was 2 halves.
1/2
So you take
Plus
the
2 halves.
derivative.
plus 1. So you add 1. When you take the antiderivative, you add 1. So that's
Oh, that's what we're doing. Yeah. That's where.
All right, here we go. So then up here, so it's negative 1/6. That is my answer right there. Hey, I wonder what the derivative of that is. Anybody got an idea what the derivative is? Shelves? What is the derivative of this thing? Shelves, come on now. What is it? What's the derivative of this dude? Don't overthink it, kid. You know, I called you because I know you know the answer, dear. We have just done the indefinite integral, a.k.a. the anti... Aha! So if you take the derivative of this, where will you get back to, dear? From whence you came. And if you wanted to check it, could you? And if you did, it better be that. And if it didn't, you screwed up. Okay? That's it. Yes? Sure. Some of that mess? Yeah, sure. I can't stress to you enough, this is one of those places where you really don't want to scrimp on paper. You want to use plenty of room to write stuff out when you're learning how to do this. After a while, you can do some of them in your head. After a while, like e to the 3. Who is e to the 3x, Mr. Groom? I bet it's 130 to the 3x. Literally, after you do about 2 of those, you're like, I got this crap. Same with sine of 2x or some such. Oh, I'm all over this. Yeah, I hope so. Sure, I hope so. But there's some that can be like tricky for a while. All right, we'll keep writing them out. Okay, keep writing them out. No, ooh, here's a fun one. If you did, now this is an easy one, friends. What if I had 1 over 4x plus 2? Notice about that. That looks squint at it. Look at it, kind of funny. Doesn't it kind of look like this? Doesn't it kind of look like that?
Oh.
And what is the antiderivative of that beast? Natural log. Now, for those of you that were not here yesterday, it's important that when you do antiderivatives, it's the natural log of the absolute value of x. There's a reason for that. When we learned the derivative, we said the derivative of the natural log is 1 over x. That's what we said. That's what we said. But that's because, what is the domain of natural log? It's straight up greater than 0. Yes? Hence, this is also greater than 0, even though we don't always say that. Okay? However, going the other way, what is the domain of this beast? X does not equal 0. Yes? So I need a function for an antiderivative that has a domain such that x does not equal 0. Well, natural log doesn't work, but natural log of the absolute value does work. Okay, so for those of you that were skipping yesterday, listen, here's 1 over x. Okay, that's 1 over x. Natural log looks like this, yes? Natural log of the absolute value is the mirror image, but on this side over here. That's where that comes from. Okay, so back over here, I'm going to do another one. So the integral of 1 over 4x plus 2, it's the same thing I just did on a different page. Look, I have u is equal to 4x plus 2. Therefore, du is 4 dx. Like, that's hot. Where? What? What's the derivative, yo? Derivative of 2 is constant, yo. That's cool. Good question. I love it. That's good stuff. I'm really pissed off by this other thing. It makes me angry.
The person?
Well, not the person. The poor person's issue that she had, that this person has. It makes me want to just be, not violent, just angry. Just.
Who's doing a good job?
Of course you're doing a good job. She's always done a good job her whole blame life. It's like saying that Coral woke up this morning and decided not to do a good job. It's ridiculous. So, natural log of u. Yes? But Mr. Grimm, no, there was no u to start with. That's right. So what are we going to do? We're going to resubstitute. ln of 4x plus 2 plus c. Voila. See? Si es bueno. Ooh, now. What?
How do you take the derivative of absolute value?
Ooh.
How would you be able to check that?
Well, now here's so here it turns out that this is a true statement. This is this. That's just a fact that you need to learn. But now if you're saying to me, Mr. Grimm, how do you take the derivative of absolute value? If that's what you're asking me, let's find out. What does absolute value of x really mean? Well, absolute value of x is the same thing as saying, look, this is equal to negative x when x is less than 0. And it's equal to positive x when x is greater than or equal to 0. It doesn't matter which one you put the negative on, the greater than, the equal to part on, okay? What's the derivative of that guy? Negative 1. And what's the derivative of this fella? That's right. So the derivative of the absolute value of x is what is actually referred to as what's called the Signum Function. And it just means what's the sign of x, positive or negative. And so later on, not in this class so much, I will mention it once in a while. You'll have this thing that's called the Signum Function. And so if I want to take the derivative at x equals negative 2, it'll just be, in this case, it'll just be 1. It'll be the signum of x times 1. So at negative 2, it would be, it's negative, so I'm going to use the negative sign. So negative times 1, negative 1. Okay? If it was, I want to know the derivative at 10, well, the answer is 1, but then times the sign of 10, which is positive, so it's positive 1. Yay. Doesn't hit us very often. Once in a while, stay tuned. Later on, we'll run into one of these guys later on this year, and you're like, Mr. Grimm, I got this weird answer. Oh, we forgot the Signum Function. Okay, I'm going to be careful of him. And all it does is take the sign of the x in question, positive or negative. That's all it wants. Nothing else about it. Ooh, here, watch this one. Watch how this one's different. Oh, weird. I feel like this one's creepy, Mr. Groom. We'll do a nice easy one. A little ego boost over here on the end. Well, that's hot. Okay. Now, that should now be 6x in there. It's 4x plus 6. That's disturbing. Mr. Grimm, why didn't you just make it 10x? That's a good question. 4x plus 6. Okay, there you go. There you go. Now, again, let's do them individually, shall we? Okay. So let's do this feller here. And then, listen, when it's all done, then I'm going to go back. When it's all done, that's when I'm going to go back and redo this a little bit, okay? If that's okay with you? So I'm just going to go to this. I'm just going to take the antiderivatives first, if that's okay with you, is what I'm saying. I guess that's what I'm trying to say. Mr. Graham, if you just shut up and say it, that'd be nice. I'm sorry. Jeez. Ouch, it's hurtful. Okay. So one thing at a time. So I'll do the hard one. 4x, that's cute. What do you think the antiderivative of e to the negative x is without doing it? That's right. And how did you do that? Because you said let's let u equal negative x, yes? Yes. And then du would be equal to negative dx, right? Well, I don't have a negative dx, so I have a negative du. You with me? Nice. And so what she is saying is, well, let's pull that negative out front and take e to the u du. And what is the antiderivative of e to the u? E to the u. And so while we're doing this, let's resubstitute in our head, if that's okay with you, okay? Do you see how I skipped that last step there, dear? Do you see it? Because this is e to the u. I mean, do I really need to write that again? I don't think I need to write that. That's dumb. Let's resubstitute back in. E's are very easy. After you see about 2 e's, you're like, I'm on this crap. Okay? It's pretty easy to do. Now, what about this fella here? Do you see a function in a function? I do. So u is 4x plus 6. So du would be equal to 4 dx. And so I've got a fourth of a du, yes? So that's 1/4. U to the 1/2. I feel like I just did this problem, didn't I? From whence did that come? It came from u to the 3/2, yes? Times 2/3. And so, and then what would you do here? Well, you'd resubstitute. Of course you would. And then what was the last thing we'd do?
Plus C.
No, not plus c, because it's a what? It's a definite integral, right? Do you see that part's no different? The only part that's different is the substitution piece. I need to find an antiderivative. To do that, I'm going to need to use substitution. Do you see that's the only difference here? At the end, it's the same, yes? F of b minus f of a. So it's going to be 1/6. And again, I'm probably going to do this on my... Oops. I'm probably going to use Desmos to do this or something, because I'm lazy. You do you. I'm going to write it out, though, like this, if that's okay with you. Because I actually want to find out what the values are. Oops, that's right. And I'm going to find out what this value is, and when I'm done, I'm going to minus them. Okay, and whoop up the old Desmos. And what was it? 4x?
4x plus 6
To the 1.5. And then what?
plus 4x
Plus 4x.
minus e to
Ah,
the negative x.
fort. Minus what?
Minus e to the negative x.
E to the negative x. Now, I did it this way. That was just dumb. What I should have done, and I was trying to try to model good behavior for you, is to put a's or something everywhere there's an x. I think this is just the easiest way to go about it. Oops, that should be an a. And then you literally can just type in the values. So 6. Oops, I said 6. Give me the 6, you hippie. No, it doesn't like my keyboard now. Sorry, keyboard. So I write 51.38 down in my paper somewhere. You see that? That's f of 6. Do you see that? I jot it down, and then I just get rid of that, and I go 3, and it's 24.6. I jot that down, and then I minus those guys, and I get like 27 or something, yes? You see it?
26.8.
26.8? Yeah. To me, that's the easiest way to use it, is use Desmos with that slider button. To me, that's the easiest way. You're certainly welcome to put x's up here in this equation and write x equals 3 and x equals 6 and find the y values. I don't care how you do it. You do you. Back in the old days, we had to type it into our stupid little calculator one at a time. I got better things to do. Okay? It's the 21st century. Use technology appropriately. Now, let's look at this one here, though, just for fun. I want to look at this guy. It was 4x plus 6, wasn't it? Yes? That's what it was? I want to look at just this piece by itself, if that's okay with you. What's the matter, dude?
Well, maybe you're going to do it. Because I know Daniel asked that question.
What?
Where did the, 2/3 and 3/2 come from?
Oh, dear.
I'm sorry.
Oh, dear. Now, listen, dear. Remember back. Listen, stop. Don't apologize, dear. Stop. Now, listen. Shh. Listen, if you had x squared, what's the antiderivative of that? Well, it'd be x cubed over 3, right? Because you add 1 and then divide by it, yes? If you add 1 to this fellow, what do you get? And then you divide by 3/2. But when you divide by 3/2, you're timesing by 2/3.
Okay.
Make sense?
Yeah.
Coral doesn't buy that. What's the matter? What's the matter? Oh, nothing.
These things. You still want to
That's fine. Seriously, that pisses me off. I'm angry about this. I went and spoke to her, and she said, I knew someone would tell you. And I said, yeah, damn right they did. All right, Aaron. Did you get it? Sit down. Does that work for you? Right, now, I want to go back to this one for a jiffy. Now, if you look at this one right here, this is kind of a big deal. You got this function in here. Now, when I was a kid, I always did what I just showed you how to do. When I did this, I ended up with, what do we get? 1/6, 4x plus, what was it? 4x plus 6 to the 3/2, right? And that's how I always did it when I was a kid. Okay? And then I evaluated from 3 to 6. You with me? That's how I always did it. To me, that made the most sense. But when I came here, the guy who used to teach calculus would get so mad when I'd help kids do it that way. Because he would skip that step. He would go right to this other step, which I think is intuitive and helpful. But if you never really caught the whole resubstitute routine, the other part made no sense at all. And so what he said was, this works. This is fabulous, by the way. There's nothing wrong with what he did. He said this, and we agreed on this part. We agreed on this part. Oops, that's a dx, stupid. We agreed on that. We all agreed on this part. We all agreed to here. Okay? We agreed down to here. And this is where we disagreed with one another. Steve said, why, Jay, why would you resubstitute? I said, why not? He says, Jay, these are x values. I said, yeah. Why don't you make them into u values, he says. Now, I know what he meant, but look what he did. He ran the 3 through this deal, and what did he get out? By God, he got out 18, didn't he? Yes? Do you see it? And then he ran the 6 through this fella, and he got out 30, didn't he? Nice. And he says, Jay, this is so much less work. That's what I called BS.
Maybe she had to put in the calculator back then.
Yeah, but literally, you still had to do 4x plus 6, didn't you? You still had to do it, didn't you? Yes. And so he said, he's crazy. He still is crazy. I love the guy. He's crazier than a hoot owl. He said this is easier than doing this. Was it 4x plus 6?
Yeah.
He said it was easier than doing this. And I said, Steve, you still had to do 4x plus 6, didn't you? Well, yeah, but it's easier. I'm like, it's not easier. It's just different. Are you with me?
Yeah.
And so you would plug in 3 goes into here, and you'd plug 6 into here, and guess what you get? The same freaking answer. I don't care. You do you. Me personally, I like the idea of resubstituting because oftentimes, like on this last problem, the one before this, when I had like 3 or 4 parts to it, yeah, some of them did, like some of it was just like 4x and like, e to the 2x or some dumb thing. And it's like there'd be no reason to do that whole U substitution routine at the end. You just put everything back in for x, evaluate it all at one time. To me, that's the easier way to go. Okay? A lot of teachers teach it this way only. They act like you're a space cadet person if you do not understand it. They act like you're weird that you would want to do it any other way. I would say that it's just easier and that's why I'm going to do it. But you do you. Okay? I personally, again, would do it. I would resubstitute from here to here, and then I would evaluate. That's how I would do it. Yet it's the exact same answer either way you slice it. Okay? It's just to me, if there's only this problem, it's potato, potato, vodka, clearly. However, if it's this guy, where it's messed up with a whole bunch of, where's it, this one? Yes, see this? Like if it's this whole nasty mess right here, for God's sakes, just make them all X's again, right? And then evaluate it one time. That's just easier, in my humble opinion. I am HL. Okay? Look at that. I can be like the big kids. It took me the longest time to figure out what that meant. I'm like, what does that mean? My humble opinion, right? In my humble opinion.
Yeah, sure.
You get it? I love when people do this. My 2 cents. That makes me happy. All right, one more time. Let's do another one here. Ooh. Ooh. No, not 2x. 4x. Nice. 3x squared plus 6. That's hot. Now, I'm going to go from 0 to 1 on this problem, just because I feel like it. So, Scream, I don't know what that looks like at all. Let me give you a hint, friend. I think it looks like this. And if u was that denominator, does du look remotely like the numerator? And before you say no, watch me move this out front. Just move the 4 out front, okay? So you're not freaked out by it. Look, friends, I have an x dx over here. Do you see that? Do I have an x dx over here? By George, I do. So I have 1/6 of a du is an x dx. You see that?
What's that for?
Whoa, 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 whoa. It was up on top,
Oh, it was.
and I pulled it out front because it was annoying me.
Okay.
I could have left it there. You do you. But some people are freaked out. They're like, no, I don't have a 6 dx. I've got a 4 dx. Well, that's weird. When I was a kid, I was good with fractions. I still am, I guess. But I've learned over time that why would you do all the god-awful fractions if you don't have to? So listen, if I pull the 4 out front, all I need to match is x dx. You see that? Well, there it is. How am I going to get there? I'm just going to divide by 6. So what I'm going to have is 4 over 6. Do you see that? Don't everybody cry about that. That's obvious where that came from. Yes? 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 That's right, Seppa. It is. And then in here, baby, I'm going to have 1 over u du. Bam! Done. But where did the x go on top, friend? X dx is a 1/6 of a du, yes? And the 6 is out front, and then the du is right there. Hey, now what is the antiderivative of 1 over u?
ln of the absolute value.
The ln of the absolute value of u, yes? Watch me skip that intermediate step. Oh, Mr. Groom, you're living dangerously. I know, there it is. There it is. You freaked me out, Mr. Groom. I know, it's fine. And we're going from 0 to 1. So in reality, I'm going to have 2/3 times the absolute value of the ln of 9 minus 2/3 the absolute value of the ln of 6, I guess, right? Whatever that comes out to be. I don't really care what it is. You do you. Okay. Again, Mr. McAtee would have come down here. He would have just said, Jay, that's 2/3 ln of u, the absolute value of u. And then he would have said, well, I feel like u is equal to 3x squared plus 6, right? And then he would have said, well, u of 1 is 9. And he would have said u of 0 is 6. So then right here, he would have been 6 and 9. So Mr. McAtee would have said 2/3 ln of 9 minus 2/3 ln of 6. And guess what we'd have gotten? Same answer! They're the same. I don't care how you get here. And for God's sakes, give me a decimal. I was just showing you, okay? It's just where, what?
After the 2/3.
Is it dem?
It's an M. What is that?
These are all natural logs. It's clearly an n. It's clearly an n. Zappa, Judas Priest. All right, now, I'm just teasing. It did look like crap. Yes, dear.
I don't know, you lost me somewhere with the 4, 6 thing.
4, 6. Oh my God, yes, I'm sorry. Listen, you with me? I pulled the 4 out front, right?
No,
Okay.
I don't know where you got the 4 from.
It was up here on top.
Oh.
And it was pissing me off. And being as this is a limit, I can pull it out front. Okay? And then from over here, here's my 1/6 right here. You see this? So I'm going to replace the x dx. So I'm going to get rid of it with a 1/6 of a du. So the 6 is going to come out front. You see that?
Okay.
Bam. Bam. We good? All right. Now, that was page, what page I said it was yesterday? Was that page 3? What? Oftentimes, people look at this one and go, oh my gosh, there's a function in a function. And they're like, I'm going to do u equals 2x plus 5. And then they're going to do du is equal to 2 dx. And then they're going to cry. Because they're like, Mr. Groom, I totes can see this squirt of u, obviously. I can see this is a half of a du. You with me? Yes? You see it? Do you see it? But what about x? Now listen, if there was only a function somewhere that I could solve to find out what x was equal to. There is! Let's do it. Ta-da! Ta-da! Thank you. Thank you. Yeah, the idea, friends, is what some books refer to as double substitution. Because after you get done, you're like, what am I going to do about x? Friend, you're going to solve for x. Here, watch me elaborate. It's u minus 5 over 2. Now, what can I do with this other 2 on the bottom there, Ms. Reardon? What can I do with this other 2 down here on the bottom? I don't like it there. What can I do with it? Can't I just pull it out front with the other 2?
Sure.
And what would that give me out front? 1 over... Well, they're both on the bottom, so it's 1 over 4. Right? Now, I feel like this is really u to the 1/2 right here. Is that correct? All I've done is rewrite things. I have not done anything different yet. Yeah, is that true? I just changed the square root of u to the 1/2, correct? Now, I feel like, Ms. Reardon, I could times this out, couldn't I? Sure. And again, I'm not doing the integral yet. I'm just cleaning up my integral so it looks prettier, so I can then actually do it. So now I've gone from a nasty, gross function to a nice, easy function that all it includes. You notice that this is just an antiderivative. It would be u to the 5/2. Is that true? Yes? U, this is just a bracket. U to the 5/2. But if I have u to the 5/2, I don't have to divide by 5/2?
Yes.
But if I divide by 5/2, isn't that timesing by 2/5?
Sure.
I believe it is. That's correct. Minus 5u to the 3/2. Is that true? The 5 is still there. I left a little room. Now, u to the 3/2 divide by 3/2, which is times by 2/3. Yes? One thing at a time. I can't do everything. Now, let's clean this mess up. This will be 10/3. Is that true? I'm going to do this in pieces. If you're better at fractions than somebody else, good for you. Don't rub it in their face. All times 1/4, correct? So I feel like this would be, I don't know, I feel like 1/10. Is that right? 1/4? Cancel. Yep. U to the 5/2. I'm just distributing the negative 1/4 through. And then this would be something like, I don't know, I feel like 5/6, I think. I feel like. Yeah. Now, we're not done. We are not done. Nobody asked about you. Nobody asked about you. It's not about you. It's about x. So let's resubstitute, shall we? What was u equal to? 2x plus... How do I know this is the right answer? How could I check myself? What's that? Well, no, I just did the antiderivative. That's right! I knew that you knew. That's why I asked you. Let's take the derivative of this piece here, shall we? Do it with me now. Bring the 5/2 out front, yo. That's 5/2 times 1/10. Is that correct? Shh, quiet. 2x plus 5 to the 3/2. Is that right? Times 2, because there's a chain rule going on there, yes? I'm taking the derivative to see if I'm correct. Minus, that's going to be 5/6 times 3/2. I'll bring the 3/2 down, yes? That's a different order. Nobody cares. Multiplication is commutative. And let's see what happens, shall we? What happens here? I feel like this 2 cancels with this 2. Is that true? And then I feel like this is just a half. Is that right? Okay. And then I feel like this 2 and this 2 cancel. And this cancel, and you get minus 5/2. Is that right? Like that. Is that true? That makes me happy. Okay, now, Mr. Groom, I feel like, does this guy and this guy have anything in common? 2x plus 5 to the 1/2 power. You are correct, dear. Nice job. That is totally right, by the way. Good job. Do they have anything else in common? They also have a 1/2 in common, don't they? You with me on that? They also have a 1/2 in common. What would I be left with if I factor that out? Well, let's do this. Let's do the easy one first. Get an ego boost. If you took a 1/2 and a 2x plus 5 to the 1/2 out of this, what would you be left with? Minus 5. You with me? Just that part, right? On that one? Listen, dear, you just factoring. Just factoring. Now let's look at this piece here, okay? If you take the 1/2 out, it's gone, obviously. Okay. What happens if you take a 1/2 out of this guy? To the 1. That's right. 2x plus 5 to the 1th power. You're right. What? Dear, I'm writing it that way first. Okay, is that okay? Can I just write like that first? I'm going to do it that way anyways. I don't care. Can you see that? Okay? Now, Mr. Groom, I don't like that 1 there. Good, I don't need it. I'm just showing it to you. But wait, doesn't the plus 5 and the minus 5 cancel? They do. Wait, Mr. Groom, doesn't the 1/2 and the 2 cancel? They do. And what are you left with? You're left with x times the square root of 2x plus 5. Which means what? That must have been the right answer. Otherwise, we took the derivative wrong somehow and ended up with the right derivative of the wrong integral. But I don't believe that. I believe we did it correctly. Okay? Again, you can always check yourself. What if, on my homework assignment, Mr. Groom, I can't figure out how to simplify it like this? That's a great question, Joe. It's like you read my mind, kid. Thank you for that, by the way. Thank you so much. Now I'm not going to wolf from alpha. No, lazy butt. No. I'm going to go to Desmos.com, and I'm going to type in my answer that I said it was. So what was my answer when I did the when I said I took the first derivative of that, what it came out to be, it was like a 1/2, and then it was like parentheses 2x plus 5 to the 3/2, and then minus 5 parentheses 2x plus 5 to the 0.5. Is that correct? Right? That's what I had for. That's what I said the derivative was. Was it? Oh yeah, 5/2. Thank you. Thank you so much. God, see, this is why I ask you questions, because you're a genius. Now, Mr. Groom, I'm not sure if this is correct or not. Here's how I would check myself, yo. That's pretty cool. Now, in other words, when I graph them, they're clearly the same function. So I must be right. Even if you can't do the algebra. I strongly suggest you do that. Okay? It's good to practice with your algebra. And yes, I'll keep doing algebra problems as we go. Just be aware you're will run into some that are just gross sometimes. So u is
X squared
Aren't you busy?
u is x squared minus 1. That's correct. U is x squared minus 1. So what's du? 2x dx. I like that. So u is x squared minus 1. Why is it that one? Oh, my. Okay, this stupid thing hasn't worked in years. The zoom function has not worked in years. And now today it's going to decide it wants to work. So let's try that again. It was what?
X cubed times x squared minus 1.
To the 3/2.
Okay, listen. So I see I have a 1/2 du. And I did that because I don't have any 2's over here. You see this? There's no 2's floating around there. So I just want to have this. Yes? What? What's the derivative of x squared, dear?
2x, Sophia. Oh my goodness.
Why no? But you're a crazy cat lady, so that's why you want. 2 to the 3/2. You with me on this? See that? I feel like, Sophia, I see a dx here. You see this? And here, if I'm going to bring this dx, this du in, you with me here like this? What is that accounted for? That is accounted for one of these x's, yes? You with me? Because whenever I bring this fella in, I bring in an x and a dx. You see this? But initially, there were how many x's out here, dear? There was 3 of them, which means I need an extra 2 of them, yes? Do you see this? So right here, in other words, what I'm missing is that x squared component, yes? If only there was a function somewhere where I could solve for what x squared equals. There is. What is x squared equal to?
Well, I'm confused why it's x squared and not x cubed.
Dear, dude. Look right here. Dude. I'm going to stick in half of a du. You see this right here? But, what is half of a du equal to? It's equal to 1x times a dx. Well, that takes care of one of these, yes? But where are the other 2? You with me? Where are the other 2? No, you're not. No, you're not, woman. Do you understand where this comes from?
Yeah.
Do you understand this process right here?
Yes.
You understand if I put this half of a du right here and right here, I am putting in 1x, aren't I? By doing that? And I went from x cubed to an x squared, yes? Because in this guy right here is an x, yes? So now I still have x squared left, yes?
Okay.
Yes, sir?
Why didn't you have to write 1/2?
I did, right here.
Oh, I didn't see.
I got you. I'm sorry, my big fat head's in the way. Now, Mr. Grimm, what is x squared equal to? X squared is equal to? That's right, brah. So I have u plus 1 to the u to the 3 halves. There you go. Now we're cooking with gas. Let's distribute that thing. So that's u to the, how many halves? Well, it's the second one is. But what's this one? What is it? I heard it. What is it? 5 halves. After a while, you get very good at that because you'll do a bunch of them over time. So that's 1/2. What's the antiderivative of u to the 5 halves? 7 halves with a 2 sevenths. Is that right? Yes, you do. When you add 1, that's 2 2s, isn't it?
Yeah. What about the dividing?
Shh. One thing at a time, lady. I can't multitask, neither can you. So the first step is we add 1 to the exponent, yes? Yes?
Yes.
So 5 halves plus 2 halves is 7 halves.
Yeah.
Yes? If you prefer, 2.5 plus 1 is 3.5. That's the same thing, isn't it? Now let's divide by 7 halves. When you divide by 7 halves, you times by 2 sevenths. That's what I did. Nice. It's 2. But dear, look, it's u to the first power. U to the first power is equal to u to the 2 over 2, isn't it? And then when you times that by u to the 5 halves or 3 halves, you plus your exponents, yes? So you get 5 halves? That's all. Okay. What?
I was confused on the 2 sevenths part.
The 2 sevenths part?
Yeah.
So listen, you add 1 to the exponent, you get 7 halves. Then you divide by 7 halves. But when you divide by a fraction, you multiply. Does that make sense? Does it make sense to you? Okay, we'll do more. You'll get there. Now watch. This is going to be, yes, you may.
Okay, I'll just ask you after this problem.
No,
Ask me now.
Well, I was wondering if, like, after this problem, you could give us a problem that we could try. And
Yeah, well, yes, that's typically my way. Madeline Hunter, the great guru of teaching back in the day, always called that guided practice. Yes, and then we'll do independent practice when you go home. No joke, when I was a kid, it wasn't about Avid, and it wasn't about Cornell notes and so forth, and this and that and whatnot. Back in my day, it was, I forget what the first step was called, and then it was called guided practice, where you work to help the children work through it, and you walk around the room and they work out examples, and you're like, oh my God, they learned it. Oh!
Never do that.
And then You did independent practice when you went home. That's what they literally called it. And then it went away because Madeline Hunter was bad. But listen, that's the only one over the years. She is the only one, who has really stayed there. I mean, that's how everybody really teaches. Except that it's passé now because that was so like, oh my gosh, years ago, Jay, I feel like. And so these other people have come along over the years and then they've flashes in the pan. Except that that's how it is everywhere in the real world. Hey, look, you're going to come to I'm going to teach you how to do something. Watch me do it. Okay. Let me show you how. Now you practice it. Oh, okay. Now you do it on your own. Okay. And there, I trained you. Go away. That's how it's always worked. Don't even get me started. I don't even want to talk about it. Stop. Just stop. Now, what if I take a half times this? What happens? This is 1/7 u to the 7 halves plus 1/5 u to the 5 halves. This is true. And then I would just resubstitute, right? And so that would be 1/7. Was that x squared? Was it x squared minus 1? X squared minus 1? Is that what it is?
Yes.
Okay, beautiful. Thank you so much. To the 7 halves. My plus 1/5. X squared minus 1 to the 5 halves plus c. Yes. Yes, I really want to do one that you could do all by yourself. Okay? That's what I'm going to do right now. I feel like. What? We'll wait. We'll wait for Coral. She's not done yet. I got that. I'm not done yet, Coral. I'll wait for you because I care. Okay. Hey, you ready now? Are you ready now? All right. This one on your own. Try it now.
Sam's sick, by the way.
Sam is sick.
Yeah.
It's interesting. His twin didn't tell me that.
That thing just looks like an S, like a giant S.
Yes.
When I mean, yours doesn't. Yours is like a, and mine is an S. It's a giant S. Too much. There we go. That's better.
So, friends, most of you did this part just fine. By the way, good job.
I'm happy.
3 halves. This is u times.
Right? And then you're like, I don't see any 3 over here. Shh. Shh. Now watch. Watch Mr. Groom substitute. This is u to the 1/2. You see that? Yes, that's easy. Mr. Groom, I'm going to replace a dx, you see this? And 2 of these guys with a 1/3 du. Do you see that? Okay? That leaves me with an x cubed left over, right? Well, I can't have it like this, for goodness sakes. So I need to know what x cubed is equal to. Well, what is x cubed equal to? From right up here, it's equal to u minus 1, correct? So that's what I'm going to do. And then I'm going to distributate. And I'm going to get 1/3. That's u to the 3 halves minus u to the 1/2 du. And then let's see what happens. Let's do this here. What is the antiderivative of this guy? U to the 5 halves times 2/5. Divide by 5 halves. Divide by 5 halves, which is the same as multiplying by 2/5. Yes? Listen. Watch. You add 1 to the exponent. So that's 5 halves. And you divide by 5 halves.
Oh, that's right.
But when you divide by 5 halves, you invert and multiply. Just be careful. Oldest mistake in the book. It's the oldest mistake in the book, lady. Now, minus. Is that true? I love how the cat lady goes from, I don't get any of this until she's already like the first one done, and it's fine. No, you crack me up. You just crack me up. You're a funny girl. So, the crazy cat lady is so redundant. The fact that you're a cat lady means you're crazy. That's fine. And then if you times this out, you're going to get minus 2/9. Is this true? Is that true? Is that true? Good. Ta-da! Okay, now, you'll notice that I kind of beat this thing to death for a couple of these, and you're like, Scrum, they all work that way? No, only some of them work this way. But yet you will go home tonight and think that all of them work this way because I spent so much time on it today. So I'm going to do another couple of the traditional looking ones so that people don't go home and go, every one of them is a double integral, a double substitution. No, it's not. No, it's not. It just happens that when you substitute, sometimes one substitution is not enough. And how do I know that? Because not everything has been accounted for. Like in this case, there was an extra x cubed floating around. I had to take care of it somehow. But sometimes that won't be true. Sometimes it'll just be like, boom, done. Move on. Yes, dear.
Will the x cubed minus 1 will be plus?
X cubed minus 1? Where are we plus at, dear?
I think it is.
Is it x cubed plus 1? Oh, I'm sorry. I'm sorry. Thank you so much. Don't hate me. All right, let's try another one. Do you see a function in a function? I feel like u is the square root of x, isn't it? That's what it feels like to me. But what would du be? And be very careful, because this is really x to the 1/2 power, is it not? What would so it'd be 1/2 x to the negative 1/2, a.k.a. 1 over 2 square root of x. Are you with me? Are you with me? No. Trace says no. Trace, do you see this, sir? The derivative of this is this, sir. Now, look over yonder. Look, I already have a square root in the denominator. Well, isn't that convenient? But you know what I don't have? I don't have a freaking 2 down there, do I? So I have this. Are you with me? I'm going to replace this garbage here. You see it? You see it? I'm going to replace that stuff there with a 2 du. And then I'm going to end up with a secant squared of u. Yes? Well, Mr. Grimm, that's just tangent again. Yes, I know. I know. I know. So 2 tangent of what? Square root of x plus c. And you're done.